Section 3, we've got functions, tables, and graphs. Pretty much our objective today is to take a function and teach you the basics behind what we're going to have you do in terms of translating the function from an equation into a visual representation on a graph. So, I've kind of listed all of our stuff here just as a review. X and Y, domain and range, input, output, independent, dependent. What is the one pair I did not list? Can you think of it? Abscissa and ordinate. Try to spell it on your own right now. See if you can put it out here, and let's just try to spell that on your own. If you need to, look up abscissa and ordinate. Okay? So just a little bit of a review there. Those are the main names for X and Y as we're looking through these. Couple definitions to review. Caroline, here we have a relation. It's a set of ordered pairs, a bunch of points. But when I ask you for the definition, I need to see the word a set, which means more than one, and ordered pairs. Is it important to put the X first and the Y second? If your points were reversed, your graphs would be all messed up. And then lastly, a function. It's a relation. You can replace that word with a set of ordered pairs, such that for every X, there's one, and you can't just say there's one Y, you have to say there's one and only one Y. So just a little bit of a difference there in terms of as we define those, we need to make sure we're solid on those definitions. What's the best way to remember the function idea of all of our illustrations that work for you? Remember that birthday idea? Every person can have how many birthdays? One. And only one. So, okay. Here we go. Model the function by making a table of at least 3 values and then graphing the function. So, we're going to try to graph our function. Some of you have done this before, so maybe some of you haven't. But we're going to pick some points and then graph the points on a line. So I'm going to start with the easiest point of all to choose, which is 0. Now I'm going to plug it in. 2 times 0 minus 3. If you need your calculator today, get it out. If you don't, no big deal. What is 2 times 3, or 2 times 0 minus 3? Negative 3. Okay, so we've got the point, negative 3. So over here, we're going to actually put pair parentheses, and we're going to put down the point 0, negative 3. So kind of add a 4th column. And then graph that point. 0, negative 3. Now we need to pick 2 more points. Pick 1. I like picking 1. It's an easy number to choose. So 2 times 1 minus 3 is how much, Nate? Negative 1. So my point is 1 comma negative 1. Let's graph that. About right there. I need to pick another point. Justin? 4. Why did you choose 4? Just because? Okay. 2 times 4 minus 3. That's 8 minus 3 is 5. So 4 comma 5. So over 4. 1, 2, 3, 4, up 5. All right. If you don't have a straight edge, take out a piece of paper out of your spiral, tear it out, fold it like a hot dog twice, and you'll end up with a straight edge of sorts. Okay? You do have a straight edge, or maybe use 2 different pens or something. So I want you to draw your lines with a straight edge. I want your lines to have a couple characteristics, and let me go over this while you're doing them, okay? First characteristic, there needs to be arrows at the end, okay? That's the first point. Second point, the line needs to go from end to end. What I mean by that is it needs to go off the graph at the one end and off the graph at the other end. I don't want your line just to be, an inch long in the middle of the graph. So it needs to extend to the edges of the graph. So kind of 2 major points there. And then third, you need to have at least 3 points on your graph. At least 3 points. So those are the three characteristics I'm going to be looking for as we're doing it. And obviously drawn with a straight edge of some sort. All right? Good there? Let's look down at the bottom. Here we have a different function, 8 minus x. Let's start with Luis's number, 0. Plug in 8 minus 0, and that's 8. Very simple. So that's the point 0, comma 8. So there's 6. It's kind of hard to see. 3, 4, 5, 6, 7. So it looks like 8 is up here. Give me another point to choose. Okay, choose 1. 8 minus 1 is 7. So 1, 7. Another point? How did I get 7? I just plugged in the point 1. 8 minus 1. I'm going to pick something a little bit further over. I'll choose 4 again like Justin did before. 8 minus 4 is 4. 4 comma 4. 1, 2, 3, 4. Why do you think I need to graph 3 points? Give me a reason. Don't 2 points make a line? So why do I graph 3 points? Give me some thoughts. Why graph 3? Well, what if these were your 2 points and this was your third point? What would that tell you? If this was 2 of the points and that was the third point, what's it tell you about your line? If you're graphing, what does it tell you about these 3 points as you plug them in? Are they all correct? So by graphing 3 points, it's going to show us that we're for sure checking our work. The third point is the check. If the third point lines up with the other 2, you know they're right. But if you get 3 points that look like this, maybe the line is like that. Maybe the line is like that. Maybe the line is like that. So if you get 3 points that look like this, what should you probably do? Graph a fourth. And if I told you the fourth point was right here, would you know which one's the wrong point? Because now when we line them up, you'll see, oh, obviously this point that we did here, that was the wrong one. So graph 3 points. If they line up, you're right. If they don't line up, then graph a fourth. That's why I have an extra blank down here in case we had made a mistake. Easy points to graph. I'll always often check or use 0, 1, and 2. Easy numbers to plug in. 0, 1, and 2. All right? So let's flip the page.